Taking a look at page 2 of your seminar, we're going to graph x squared plus 2x plus 3. So if we go ahead and we graph that, there is our related equation, y equals x squared plus 2x plus 3. Notice it doesn't cross the x-axis, so there's no solution. And probably should have written down my work here. So we graph y equals x squared plus 2x plus 3. And then there's no solution when we graph that because it doesn't cross the x-axis. If we take a look at example 4, not everything's going to be a nice whole number. Probably could have figured that out to start with. So if I have y equals x squared minus 4x plus 2, to get the solution, we're just going to round. So if you graph that related function, and the nice thing about decimals is it rounds for you. You're going to have to round to the nearest tenth, but it gives us a rounded answer. So I'd say x would be about 0.6. So I'd say x equals, or maybe I'll say x approximately, is 0.6, or x is about 3.4. And that's what you would do in that one. Now, on an application question like number 15, first off, I'm going to replace all of my variables. I'm going to use x and y instead. So she built this model rocket. The equation is negative 16t squared plus 250t. It's going to be launched from the ground level, so that's why my y-intercept is 0. My velocity is 250. That's why we put the 250 in front of the t. H is the height of the rocket after t seconds. How long was Kinsella's rocket in the air? Well, really, I want to find when is Kinsella's rocket back on the ground, and that'll tell you what the air is. So I know the height of the ground is going to be 0. And like I said, instead of using t, I'm going to use x's. So I'm going to say negative 16x squared plus 250x. Well, then I'm going to graph the related function. And we run into a problem on this one because the numbers are so ugly. That 250 is a huge number. We haven't solved one like that. So if I go and I graph that, it looks like it's just a vertical line. So I better set my window so I can see my parabola. So in other words, I have to go back and do what we did on the previous assignment. I'm going to find my axis of symmetry so I know about where I need to go. So negative b over 2a. So I'll go negative 250 over negative, or not negative, all over 2 times negative 16, because that's our a. So I get negative 250 all over negative 32. So if I take 250 divided by 32, we'll just use the calculator for that, 250 divided by 32. That tells me I get about 7.8, don't I? So I know the maximum height of the rocket is at 7.8. Well, if I think of a rocket here, it's going to go up and it's going to go down. So I know my rocket is going to go out, let's double that. So double 7.8, and that turns out to be like, let's go with 16. So in other words, I'm going to go in my graph, I'm going to click on the wrench, I'm going to change my x from 0 to 16. Negative 10 might have worked too, but I'm going to go 0 to 16. Now do you see, I see part of my parabola at least. There's one line, and the problem is I can't see the top of my parabola. Well, let's see what my top of my parabola would be. Well, the top of my parabola is going to be, y is going to be negative 16 times 7.8 squared plus 250 times 7.8. Well, I think we could do that in our calculator. So we're going to take negative 16 times 7.8 squared, and then plus 250 times 7.8. So the top of my graph is going to be 976. So I'm going to have my graph go up to 1,000. So I'm going to click on my wrench here, and now I'm going to adjust my y. I'm going to have y go from 0, well, actually, I like negative 10. Let's go negative 10, so we have a little bit of margin, to 1,000. Now, do you see? Now I can see my, well, parabola, but I want to go down here to 0. Now I can see my parabola. Notice my x-intercepts at 0 and 15.6. So the rocket's in the air for about 15.6 seconds. And obviously we can adjust that with your finger too, or by zooming it in. So we're going to say 15.6 seconds. It'll be in the air. If you put 15.6 on the test, you will not get full credit. You must put the units on there. It'd be nice if we put a complete sentence, but at least put the minimum of 15.6 seconds.